What up, guys? Welcome to part 3 of the 3.4 transformation of functions video. This happens to be the easiest and last one. So let's go ahead and check it out. All right, so this one is the reflections part of the worksheet. All right, reflections. So how can we flip a function, as we've spoken before, vertically or horizontally? How can we flip a function either vertically or horizontally? Like always, I'm going to go ahead and show you pretty much what I'm going to be doing. And these are our two options. So we have our parent function, meaning the starting function f of x, and we're going to wonder what it does when we multiply it by a negative. And very important, the number doesn't matter. Right now, I don't want you to focus on 1. And I don't care if it's a 1 or a 47 or a 52. The negative is what we're focusing on. If the number that we're multiplying it is a negative number, you're going to see what happens because of the negative, not because of the number. It's kind of weird to say, but because of the negative. And I'll show you right now in Desmos why the number doesn't really matter with what we're talking about right now, but just the negative. So we're going to talk about what it is or what it looks like when we multiply once again, the f of x, meaning the whole function, meaning y. What happens when we multiply y by -1, or what happens when we multiply the x directly by -1. So without further ado, let's go ahead and jump into Desmos. In Desmos right now, I'm going to use a function that we haven't seen at all, and it's called the square root function. And the reason why it's the square root function is because this one is going to be the function that will make it easier to look at. Trust me, it's going to make it easier to look at with what we're going to talk about right now. Okay, so we have this function right here, and I'm trying to wonder what happens when we multiply inside or outside by a negative number. Now, really quick, let me give you an idea of why we don't care if it's a positive or a negative number. Or I'm sorry, we don't care about the number. We care about just the negative. For that, let me just jump back to the function that you guys are pretty much familiar with, which is the y equals x to the second power. That's the quadratic. All right. So if I multiply this quadratic function by, let's say, 5, hopefully we remember that this will be a vertical, there's going to be a vertical stretch, so it makes it narrower. Okay. Now, what happens if this 5 was negative? Okay. What happens when that 5 is negative? Did this negative make it any more narrower or wider? No, what that negative does, it just flips it upside down. The 5 has nothing to do with flipping it upside down. The 5 causes the stretch. Now, the negative flips it upside down. The 5 causes the stretch, okay? Again, I can take this 5 away, and no longer is my function stretched. It's back to normal, back to the parent graph. Oops, sorry, let me take this negative away. Here's my parent graph of the quadratic, and let's go ahead and add that negative again, just so you could see that the negative makes it, or the multiplication of a negative makes it flip, okay? Now, let's talk about where are we flipping. Are we flipping up and down, or are we flipping side to side? For that, we are going to be looking at this function right here, all right? This function will help us know if we're flipping up and down or side to side. So the first thing I want to do right now is I actually want to grab this function right here, and I'm going to do a little review, or I'm going to do something that we've learned already in the past, which means I am going to shift it up some units, and I'll shift it to the left some other units. We've already learned how to do that, so hopefully you can catch on with what I'm about to do right now. So I want to take this purple one, sorry, this original red one, the original red one, and I'm going to translate it as the purple one. I'll go ahead and make it go up. Let's make it nice and pretty with this 5. So I'll make it up 5. So I'm going to add, notice that I want to be outside right now of this little square root house. So I'm going to be outside plus 5. Notice that the plus 5 is outside of my little square root house, which is the equivalence of being outside of parentheses. Okay? So I don't need the parentheses. I just need to stay outside of my little square root house. Then I'm going to make... I'm going to go ahead and move to the right. I want to move to the right 5. So I want this point and every other point to move to the right 5. So that means that we need to, inside of our function, we need to take it to the right, which means subtraction by 5. And there it is. So here we are. We grabbed our parent function, the square root of x, and we went up 5 and to the right 5. Now, The reason why I'm doing this is because I want to know what happens when we have a multiplication or a negative outside of my of this square root, outside of this entire thing, right? So what I'm going to do is I'm going to go ahead and press settings. I'm going to go ahead and duplicate it twice. You'll see why. I'm going to change my color. This one, let's turn it red, and this one, let's turn it green. What color is this one? I think that one's black. Oh, that one's red already. So let me make my original one. Let's keep it black as the go-to original one. All right. So I'm no longer going to look at the original, or actually, yeah, no, I'm not going to look at the original. Yes, I am. Yes, I am going to look at the original. I'm going to look at the original. And from here, I'm going to go ahead and say, okay, let's see what happens when, and I'll put parentheses just in case you guys freak out or don't freak out, when there's a negative outside, say a negative, right? What happened? What do you notice happened? It reflected. It reflected over the x-axis, okay? It reflected over the x-axis. So I'll take that negative again, and then I'm going to go ahead and put it right here, multiplying it with the x. Boom. What happened? The reflection was no longer over the x-axis, but it was over the y-axis. Okay, now this should kind of make sense. Listen to why this should make sense. If you can look at these points right here, look at these points that I'm highlighting. All these points that make me go to the right are my x points, right? My x points, right? That's why my function goes to the right, because we have positive x points, right? We have 5, 10, 15, all these x points. Right now it's 4.23, so on and so forth. These are all positive. What happens if I grab all these x numbers, right? Look at what's happening. I grab my x numbers and I make them negative. Wouldn't that mean that now the point that used to be at 5 is now at the negative side? That is why it flips over the y-axis. If you're wondering, oh my God, this is confusing. I thought we were multiplying the x so it would go over the x-axis. I know that's what a lot of students might think, but we are multiplying x numbers by a negative, so that's why we are flipping them over into the other side. Okay, flipping them over to the other side because they were once positive numbers, now they're negative numbers. All right. Now, likewise, let's go ahead and go back to this one. What happened when we multiplied by a negative outside? What happened when we multiplied by a negative outside? We flipped over the x-axis. And to talk about that one, just like how we did with the other one, remember that we grabbed the entire function, and the entire function is represented by y. This is just the same thing as saying that we made all our y numbers negative. So before, all our y numbers, meaning our function is positive right now. Look at all the y numbers. Right now, my y number is 1.127. And if I move this way, now my y number is 2. My y number right here is 2.966. All these y numbers, you could tell, obviously, because I'm above the x-axis. So if I introduce my y numbers to a negative, they all flip over the x-axis. Now, just to show you that again with some functions that are not on my lines, on my axes, here it is. I'm going to show you and I'm going to prove it to you guys. I'm going to go ahead and grab all of this, which is represented by my y, isn't it? All of this is y. So what happens when I multiply by a negative? Where did it go? It jumped over the x-axis. So I want you to think of this right here as a line of symmetry, your x-axis, and that is what happened to it. I negated all my y numbers. You made them all negative. So now instead of you being in the positive side, there's a mirror line, which is located at your x-axis. So we reflect over the x-axis. Now, let's go ahead and see what happens. Let's put this back. Actually, let's make this let's make this right now our our original one. Let's call that our original one. And then let's do what we just did right now. Negate the whole thing in red. Okay, there it is. You can see the change. So we went from purple to red. And now let's see the difference between, having the negative multiplied by the entire thing, which is y, or having the negative multiplied directly to the x. Let's see. Here it is. Once again, we are making our x numbers negatives. That means no longer can our function go to the right because these are all positive numbers, right? If this is 0 and you're looking to the right of 0, 20, 40, look, 10, 20, these are all positive numbers. So if I, instead of making them positive 10, positive 20, positive, all that stuff, that means I will have them now in the negative section. Cool. All right. So this is what we're going to go ahead and do. Let's go ahead and wrap up all the information that we did and put it on in a little pretty sentence. Here it is. When multiplying the independent, meaning the y's, by a negative, the function reflects over the x-axis. When multiplying the independent, meaning the y's, by a negative, the function will reflect over the x-axis. This one, when multiplying the dependent, which is the x, when multiplying the x by a negative, the function reflects over the y-axis. Over the y-axis. Okay. Now, we're pretty much done here. Just as a little bonus to this section here, I'm going to show you why I don't use the functions that we, like a quadratic function. I'm going to show you why I don't like using this one to show you guys reflections. Let me explain to you why. Boom, bada boom. Let me create another one. Okay, let's make the black one the original one. Okay, so the black one is the original. Let's see what happens with the purple one if I multiply by a negative outside. Okay, by a negative outside, we learned that we will reflect over the x-axis. By a negative outside, we learned that we were reflecting over the x-axis. So it's going to go downwards like this. Got it. Gotcha. Now, I need to make a snippet of this because what I'm about to explain is very difficult to imagine. Okay, so let's go back to here. All right, so very easy idea that this right here, I'm going to try to, as much as possible, make this. Ooh, that was pretty good. Fire. All right, so obviously, you could tell that it went from here and it reflected over the x-axis. So it went like that, right? Now, what I'm going to show you is how instead of reflecting over the x-axis going that way, what's actually going to happen is that we're going to reflect it over the y-axis. So no longer are we going to have the purple one here. That means that this will be reflected like that. So this arm will be on this side and this arm would be on that side. All right. Don't you already see what's going to happen? What's going to happen is, watch this. Let's say I decide to, look what I'm going to do right now. I'm going to flip it left to right. This is literally what's going to happen. Flip. Did you guys see that? Did you catch it? Did you catch how subtle that was? Back, forth, back, forth. Do you see why if I go to decimals right now, the graph is not going to change? Because if it flips, it's going to land. This shape is symmetrical, so you're not going to see that change. Watch it. Check it out. So we obviously can see this one because obviously it doesn't overlap. It doesn't land on itself. But if we put the negative inside with the x, remember, kick out the power of 2. Look at the red one. So the red one exists, right? Look at what happens when I put the negative. Nothing happens. So I'm going to take away the negative, put the negative, nothing happens. But it does happen with my other function because it's a little bit more obvious. Watch it. I'm going to put the negative right to the x, right? Watch. Boom. Oh, wait. Sorry. The negative is supposed to be in front of it. There. In front. So this one I can tell because this one is not a symmetrical shape. So you could see that this side, the arm jumps to the other side that way. So that's pretty much why it's almost impossible to show you guys how it reflects if it looks pretty much identical, the u and the v function. So the quadratic and the absolute value function. All right, people, we are done with reflections. Make sure you get those good notes for your next quiz. Stay tuned for the practice problems. Peace out.